Hey folks, this is Mike from KEI Fabrication. This is my LS swapped Mazda B2200. If you're new to my channel, go back and check out some of the modifications we've done to this to make it a road racer, a circle track racer, and a drag racer. It's in the process of undergoing some more transformations. You'll see updates on that soon. Alright folks, I had mediocre success with the emergency brake cable, so I'm about to pick it up and take all the wheels and tires off for two reasons. First thing I'm going to do is adjust the emergency brake shoes that are inside the rotor on the rear, and then the next thing I'm going to do is I'm going to make an attempt to shorten my steering arms. I've been waiting for the right opportunity to do this, since how I've got some time ahead of me without needing to drive anywhere. I'm going to make an attempt at shortening the steering arms and add Ackerman for the purpose of drifting. So what I'm going to do is a quick before study here for the turning, and right now I'm at about 3 degrees on this side of the zero. This is 0 here. I know the numbers are hard to read. So let me see if I can get you some stock steering angle information for the B2200. Okay, that's full lock to the left. And if you add the 3 degrees that was there, this is 27 plus 3 makes 30 to the left. Let's see what happens to the right. And it has about, I'd say, 32 degrees. It's on 35 right now. You subtract that out. So one last thing I'll call out is the number of turns lock to lock. So let's see what that's all about. That's full right. It's 3.5 turns lock to lock. And that's back to center. So 3.5 turns full lock to full lock. So let's see if the shortening steering arms makes any significant improvement or creates some problems somewhere else with the interference under the truck. So right now when I turn this all the way this way, I don't know if you heard it smack, but it was hitting on, this is the factory point on the control arm, where it makes contact with the, this right here, where it makes contact with the steering arm. And it used to have a threaded bolt in here with a lock nut on it that protruded so you could adjust the stop when it hit. So that's going to get cut off when I do the process to move it around. So I'm going to take this over to the bench, build a fixture, and start shortening this thing up. Okay folks, so I got the fixture under construction. I had this big old piece of galvanized angle iron left over from when I modified a powerboat trailer to fit my sailboat. So I raised this up off the bench enough so I had some places to actually work underneath this if needed. And this is horizontal with the ground. As it turns out, these two are horizontal. This is horizontal as well. And I've drilled holes in my weld table to receive this angle iron, and I have perfectly, using a vernier caliper, aligned this an accurate distance from the edge, so I can use this edge as a reference when if I need to place this after it's cut. So I am building using the same piece of angle iron to do the same thing on the opposite side, because this is these tie rod steering arms that receive the tie rod ends are a mirror image of each other. So I'm hoping that I can just bolt the passenger side on here and hopefully use the same fixture for locating this pin. Speaking of the pin, I got my old tie rod end that I saved in case I got in a wreck, that I would be able to put the front end back together to get it back on the trailer or even drive it home. I'm going to cut this and get this out of here and utilize this pin to help me locate the steering arm in its new location. In case you ever wonder what's inside a tie rod end, there's a nylon or Teflon bearing that in the socket that the ball rides on. By the way, if you ever have to do a knee or a hip replacement, just cut one of these apart and install it. You'll be good to go. Alright folks, let me show you what I'm up to here. So what I've done is I've scratched out some lines, which I'll show you in a minute, on my weld table, and I've built this little stanchion that the threaded portion of the tie rod end threads into, and I've got this plate. Now this is 1 inch further back than stock, and this, where it is now, is 1.5 inches further back than stock. You saw me tack weld the castle nut to this sleeve, and I want to show you why I did all this. What I have is a stud that I made from a 1/2 inch bolt that threads into this plate. In order for this fixture to be ambidextrous, left or right, I have to be able to make it so this plate will flip 180 degrees. This stud will thread in, and this will go on, and obviously the tie rod end will be in here and set back on for the passenger side. To make it ambidextrous, I've got to take this plate So what this will do is, I've got a fence basically with this cutout goes up against the fixture plate, and what I'm going to do is I'm going to weld some tabs on this and through bolt it, or somehow figure out how I can make this ambidextrous and flip over to the other side. So something has to be removable. Worst case scenario, I have to make up 2 of these and I can just tack weld them. I was trying to make it so I could use everything on the left and right sides. The other thing I could do is actually just physically clamp these to the table, and then I'm not fastening it to the fixture and creating an issue when I go to flop it over. So I'll show you in a minute how this is going to position the tie rod end socket. Alright, the first thing I did was I used a center punch to index where the original location was. From there I went back an inch and scribed a line, and then I went back an inch and a half and scribed a line, and then in this direction, I don't know if you can see it with the there's a line right here that I scribed from this edge. I went an inch further back, so here's my inch further back towards the rotor. There's my inch further rearward to increase my steering ratio, and while I'm going to tack it either here or here first and see what it does over there on the fixture when I tack it all together, when I put it back on the ground, and I'll see what I gain for steering angle. So I can see whether or not either one of these two are going to work better or worse. So what ends up happening, I don't know if you can see it or not, but the cross hatches that I made in the table are lined right up with the center of these 2 holes. And then I'll put the studded fixture back together. Oops, I just dropped the piece. So this is going to go here, and what will end up happening when this is cut free, I'll move it over here and I'll thread this in, and it'll capture it at the perfect height and the perfect position. And what this will do for you folks, if you decide to have me do this for you, is make it repeatable. So we'll be able to do this over and over again. And now it's just up to me to figure out whether 1 inch back is going to be the most beneficial or an inch and a half back. And that really depends on when you turn the wheel left and right. Do the tie rod ends get super close to the lower control arms or anything else that's in the way? So I'm going to quit for now. I'm going to cut this off next, and I am going to clean it up real good everywhere and place it in the fixture and basically fine-tune this so I've got a nice surface to weld to, figure out my gusseting. I'm going to tack it together first, remove it, and then put it over on the truck, hook the tie rod end up, turn it left and right, and just keep an eye on my geometry and if there's any problems I created in terms of interference. Alright folks, I think I've got it figured out. So my little fixture here will be ambidextrous. I drilled a hole in my table. I milled a right angle corner in this bracket, and as long as I use the same bolts and bolt holes, this should go pretty good and be repeatable. As I showed you in the last segment, the little clip, my center marks are exactly where they need to be to get us the 1 inch inboard and either 1 inch or 1.5 inches stepped backwards. And this little fixture here that registers the bottom of this and also the orientation of the pin itself will work on either end. And obviously when I cut this loose, I'll use this to hold it in place. The reason why I haven't taken it apart is I'm only going to ruin one arm at a time. You know, this is all in the name of science and experimentation. So if I take this portion of my fixture, okay, that come out pretty good. When I unbolt it and flip it over, I'll obviously clean that up good. Still not too late to turn back. Here we go. We're going to head into territory where I can't necessarily go back. So that's okay. Have no fear, right? Oh no, what have I done? Alright, so what I've done is just modified the fixture a little bit. I put 2 3/8 precision ground flat stock in there, and I've moved it 3/4 of an inch this way. So if this works out, we'll gain a 1/4 inch of Ackerman. I've estimated how far I have to cut it back, and this kind of comes flat and then starts to turn up, so I'm going to cut it like right at that transition. That should still get me the 1 inch rearward and still gain as much steering angle as I can. I can't go to the 1.5. It's just not worth creating that kind of or that many problems trying to achieve that much. This is way more than what it had, and we'll see exactly what it ends up with when I tack it together and test it in a while. So I'm going to trim this off, double check my fixture, and make sure that the alignment is correct, and then I will dress this up good and like prepare it for final welding, and then tack it on there and go try it out on the turn plates. Cut it twice and it's still too short. Alright folks, it's tacked together, and obviously the suspension is at full droop. One of the things I was worried about, I don't know if I can smoothly transition you over to what I want you to look at. But one of the things that I was worried about is the interference between this arm and the tie rod end at full lock. Right now the steering is at full lock to the left, and I can fit my entire finger through there, which will provide a ton of clearance when the suspension sags. Let me see if I can get a better shot of it here. So there's the distance between the tie rod end and the steering arm. So when I set it down with the tires on it, I'm going to pay real close attention to that, and that was one of the reasons why I didn't want to move this out towards the rotor any closer, because I was worried about the interference that I may end up having as a result of that. So it's really difficult to predict that on the bench. I'm hoping what I can do through this angle here, I took a before shot of the, you can see the lower ball joint center line is right here. Maybe you can't. So the lower ball joint center line is right here. The upper ball joint center line is right here. And the tie rod end is clearly to the outside of that line. So there is at least a slight increase in Ackerman. Hopefully we'll get some before and after realization of that. So one of the ways I know that I'm getting more steering angle is, hopefully you guys can see this, this is the factory bump stop, and you can see that the steering arm is making contact with it. So I'm going to trim these off just to make sure that my steering box is at full lock. I don't know if you can tell, but man, that looks like a dramatic increase in steering angle. Alright, there's full lock to the right, and I have 2 inches of clearance between the strut rod for the lower control arm, and it looks real close here for the steering arm and the steering box. Let me see if I can get a better angle, because it's really not as bad as it looks. Let me get square to the tire, see what I can get you. Alright, so there's the space between the steering box, and there's probably a good inch there, so I've got room to go with a larger diameter tire if necessary. So far I like what I see. Alright, moment of truth. Holy cow, it's up to 45. Let's see what we got for clearance everywhere else. Alright, let's try it in the other direction. And that's full lock. I don't remember what my zero was. I'll have to look at the video, or I'll put it back where it was. So the next thing I'm going to do is take a look at the clearance for the tie rod end and stuff. Alright folks, I obviously went through the test phase of bolting the thing up onto the truck and turning it back and forth, and I was pleased with the results, so I welded it up. I made several passes here. I've got a root pass, and then a pass high, a pass low, and then I went in and ground it off and put a radius in there, and then did another root pass and then another pass on the top side. Because the arm used to be much fatter and come out further, it made a little step here. So I'm going to compensate for the loss in that strength in a way I'll show you a little later on. Same thing here. I did a really aggressive root pass, and then a pass up top and a pass down low. And what I'm going to do is I'm going to gusset the bottom of this. I'm going to come all the way out to here, and I'm going to lay in a piece of material that comes up and possibly wraps around the radius here a little bit, just to go the extra mile. So I'll show you all that when it's done. Alright folks, I just made up a gusset. I used CAD, cardboard aided design, to come up with what looks like the head of a wrench, and I'll show you how that fits. I just cut it out on the bandsaw, and you can see how these pieces all nicely come apart. And I tuned up the edges on the belt sander back there to make those edges all nice, like it was done in some other means besides a bandsaw. So let's go see how it fits on the steering arm. Alright, so the reason for the gusset is when I moved the tie rod end tapered piece rearward and shortened the arm, the bottom moved further away from the bottom of this by the chunk of material I removed. So rather than having a narrow section width here to rely on to connect the two together, I built this gusset that's going to come up and weld on. It's going to weld along here. It's going to wrap around the side. What I'm going to do is weld this along, and then I'm going to put an adjustable wrench on here while it's good and hot, rotate it down, and it'll come along the side of this instead of sitting below it. So I've got a nice pocket that I can get some good penetration all the way to the bottom in here, and then once this is tacked in place, I'll flip it over and weld underneath. So what I'm going to do, just because I need a little confidence booster, is I'm going to tack it in a couple of spots. I'm going to go stick it on the truck and make sure that I didn't create any interference issues either with the rotor or the steering arm or anything else. Alright, let's see what the new steering arm change gives us. Ooh, look at that angle. Okay, this is the driver's side, and you can see that I'm 3 degrees. This side is 0 with the steering wheel straight, and that's just because of the position when I set it back down on the turn plates. So this is to the right. Definitely have some more turn back with the increased caster. So I got to give it a little help here. So that's a total of 42 degrees in this direction. You can't see it from where you are, so let me move it back here because the tire covered up the So if I hold it against the stop like I am now, remember I said it was plus 3 degrees, so it's at 39 plus 2, roughly 41, somewhere in there, 41, 42 degrees. So that's back to 0, which is still 3 degrees on that side. So let's see what it does in the other direction. Again, with that increased caster, it turns back on its own a little bit. So let's see what we got here for a number. I know this is tough to see because of the lighting and everything else, but if I hold it against the stop, remember it was +3, right now it's at 44, so -3 is 41. So it's almost 10 degrees increased in either direction. Now that might not be a lot for the average drifter, but it's 10 degrees more than I had. So the biggest thing is I'm going to test the drivability here in a little while. And I'm happy that my alignment is done. I'm happy my steering arms are shortened. So now it's just a matter of seeing how the drivability and the changes that it made with the quicker steering arms and the increased caster, that should have increased the steering effort significantly. The real telltale sign is going to be, will it have enough power steering pump to overcome the increased effort? If not, I guess I have to work out more. Alright, I'll let you know what happens on the drivability test. Alright folks, after shortening the steering arms, I've been driving it around quite a bit, and there is slightly increased effort in the steering wheel. That's not a problem because of the power steering, so that doesn't bother me at all. And the turning radius has been radically improved. So right now the front bumper is probably a foot away from my garage door, and we got that stone wall right there. And the circle that I can maintain, you can see I'm missing that wall no problem. And just the standard width of a driveway. Coming back around. So I'll get a measurement on that for you. So just to make it a little more scientific, I just put my square to the ground and I put a mark there. I'll drive around to the other side to wherever that happens, and then I'll get a diameter, cut it in half. If anybody wants to do this experiment for me with stock steering arms, please do so and post a comment below on what the stock turning radius is, and we'll have a comparison. So there's a measurement from one side of the circle to the other, which is the diameter, and we're getting 20 foot 4 inches. So if you divide that in 2 to get a radius, we can measure it either way, the diameter or the radius. The radius will be 10 foot 2 inches. So anyway, let me know what the number is for a stock one.